Good evening, everyone. Today, we'll take a question of trigonometric ratios. And question is given like, we have to prove the following. So, tan A upon 1 minus cot A plus cot A upon 1 minus tan A equals to 1 plus tan A plus 1 plus cot A. So, we'll start this question from the left-hand side, known as LHS. So, first of all, we'll take LHS. LHS. So, we know that tan A is equals to sin A upon cos A. So, we'll break tan in terms of sine and cos. Also, we'll break cot in terms of sine and cos. And we know cot A equals to cos A upon sine A. Now, we'll just apply both of these formulas in the given question, in the LHS. So, it would become like sine A upon cos A 1 minus cos A upon sine plus cos A upon sine A 1 minus sine A upon cos A. Now we'll simplify it further, taking LCM in the denominator. Sin A upon cos A upon sin A minus cos A. LCM would be sin A only. We'll do the same thing in this term as well. Cos A upon sin A. LCM would be cos A here. So it would become cos A minus sin A Now we'll simplify it further. So this will go and multiply with this, and this will multiply with this. Same in this case as well. This will multiply with this, and this will multiply with this. So it would become sin square A upon cos A sin A minus cos plus cos square A upon sin A cos A minus sin A. Now we see that this term and this term can be similar. How this can be similar? If we will take minus common from this term, it will become sin A minus cos A. So we'll do the same thing. Sin square A upon cos A sin A minus cos A. Cos square A upon sin A into minus sin A minus cos A. Now this sign will go in between, and we know minus and plus become minus finally. So we'll do the same thing in the next step. Sin square A upon cos A sin A minus cos A it would become minus cos square A sin A sin A minus cos A. Now we can see we can take sin A minus cos A common from the terms. So we'll do the same thing here. In the next step, we'll bring out sin A minus cos A as common. And the left terms would be sin square A upon cos A minus cos square A upon sin A on sin A. Close the bracket. Now we'll take the LCM in the bracket. 1 upon sin A minus cos A. And what the LCM would be? Sin A into cos A. And here it becomes sin cube A minus cos cube A. Now, in algebra, we just got to know about the identity of A cube minus B cube. What was it? It was A minus B multiply A square plus B square plus AB. Here what A is? Here what A is? A is sin A. The value of A is sin A and value of B is cos A. So we will just apply this identity here. And what we'll get in the next step? In the next step, we'll have this term as it is. And what about the bracket? It will become sin A minus cos A sin square A plus cos square A plus sin A into cos A, and denominator will be as it is, sin A into cos. Denominator would be as it is. Now in the next step, in this step only, we can simplify it further. We can see sin A minus cos A could be cancelled out, and also we know that value of sin square A plus cos square A is equals to 1. This is the identity we have done. So we will just put this identity here. We'll just put this identity here. And it would become, what the next step would be? 1 plus sin A into cos A upon sin A into cos A. Now we'll break the LCM and we'll have sin A into cos A plus sin A into cos A. Now this will get cancelled out, sin A to sin A, cos A to cos A. And we know one more thing. We have also read that 1 upon sin A is equals to cosec A. This we have read. Also 1 upon cos A is equals to sec A. Now we'll put both of these values here and here. And what we'll get in the next step, the final step, cosec A into sec A plus 1. Friends, we cannot solve LHS further. So now what we will do, we'll take the RHS. We'll take the RHS. What RHS was according to the question? It was 1 plus 10A plus cot A. Now we'll do the same thing what we did with the LHS. That is, we'll just break it into the sine and cos. And what we will get? Sine A upon cos A plus cos A upon sine A. Now we'll take the LCM. We'll take the LCM. What LCM would be? Sine A into cos A. This is the LCM. Here, first term we'll get sine A into cos A plus sine A into sine A plus cos A into cos A sine A into cos A plus sine square A. Multiplication of sine A into sine A would be sine square A, no? So this would become sine square A, and this would become cos square A upon sine A into cos A. Just before we discussed that the value of sine square A and cos square A is equals to 1. So it would become 1. Next step would be sine A plus 1 upon sine A into cos A. Now we will do the same thing what we did in the LHS. Simply we'll break the LCM here. So it would become sine A into cos A on sine A into cos A plus 1 upon sine A into cos A. Sine A will be cancelled out from sine A, cos A will be cancelled out from cos A. A little bit before in the LHS, we just got to know about 1 upon sine A is equals to 1 upon cos A, and 1 upon cos A is equals to 1 upon sec. Oh, sorry, 1 upon cos A is equals to sec A. So we'll put this here as well. Here as well, we'll put the same thing. So it would become 1 plus cosec A into sec A. This is the solved RHS. So friends, we can see LHS and RHS became equal. LHS and RHS became equal. So we can write LHS is equals to RHS. Hence, true. I hope this gave solution to your doubt. Thank you very much.